Alright, hello class. I am going to show you today how to make your Excel spreadsheets that go with the Lynx Lab reintroduction to the Lynx. So I'm just going to go ahead and look at the Lynx reintroduction lab real quick. And this is the directions for the lab. So assuming that you have read through all of this section in the lab, you'll be given a data set, some samples and images, and then your lab report form. The data set that you see is the circumference of some trees and their age, and you'll see this for two different forests, the Gunnison National Forest, and if you continue to scroll down you'll see it's also here for the San Isabel National Forest as well. Another piece of information you'll be given are some sample tree core rings, and these are for 20 trees that you're going to be doing your data analysis with. If you scroll down you'll see all 20 of them. And the way that you calculate the age of the tree by looking at tree bands is by adding the number of black and white bands that you have together, and those equal 1 year. So this black and this white is 1 year. So this tree is 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13 years old, while this one's a little bit younger. It's only 6 years old, and so forth. And then you'll have your normal lab report form. You should also read your background information on what type of environment is more suitable for the Lynx, and there's a web quest and the web quest worksheet that you can use to help you with that. And then you're given this other data set. So how can you go about measuring tree health and age distribution to determine whether the two forests are suitable for lab introduction? So you want to see which one is the best forest to reintroduce the Lynx to. So you're given this data table that has the tree numbers 1 through 20, the height, the circumference, the diameter, and the number of branches. So you need to figure out which of these variables correlates best with the age of the tree. Does the number of branches best tell you how old the tree is? Does the diameter tell you how old the tree is, and so forth? So that's your sort of first goal in this lab. So the first thing you'll need to do is determine which of the variables correlates best with age. So first thing you'll want to do is take a look at those 20 trees and figure out the ages. And what I'm going to do is open up an Excel spreadsheet so that we can make this data represented a little bit easier. So I'm just going to highlight this graph right from our course, and then I'm going to right click, copy it, open up Microsoft Excel, click in the first box, and I'm just going to paste it with Control V. I'm just going to spread out my columns a little bit so we can see everything a little better. And then I put some directions down here on how to make the graphs. But before we do that, I'm actually going to add one more column for data in here. So I'm going to click on column B, right click, and hit insert to add a new column. And the column I'm going to add is going to be called age. This is where we're going to put the age of the tree. So if you open up that tree ring data sheet that you were just given that we looked at, you'll see the tree rings for the 20 different trees. I have the first couple of them that I'm going to put in just so I can show you guys how to do these graphs. Okay, so here are the first 5 trees. The first one is 13 years old, the second one's 5 years old, and so forth. So to draw our first graph, you're going to click and highlight age versus height, and you do that by selecting your first data set, holding down your mouse key or your mouse button, and scrolling over the data you want to graph. Naturally, you're going to have all 20 trees in here, so when you graph, you're going to be graphing the whole thing. But because I only have a couple selected, I'm just going to select what I have, what I've entered. Then I'm going to go to Insert, and the type of graph we want to use is a scatter plot graph. So I'll click that, and I'll select one that has the lines connected. Hit it, and then voila, we have our first graph. You can click this and you can drag it to wherever you want. The problem with this graph is because we're going to be making a graph of age versus height, age versus circumference, age versus diameter, I don't really know what this one is. I mean, I do because I just graphed height, but when I'm looking back at it later, I want to make sure I can identify it too. So you're going to want to make sure that you give it a title at least. So if you look at this box up here, you can click that, and now you have the option to put in a title. Click inside that box, and then you can give it a title. So this was our age versus height. And then we're going to want to graph age versus circumference. So highlight your age category, and you're going to want to select the Control key so you can highlight a section that's not right adjacent to it. Then we do the same thing. We go to Insert, Scatter Plot, and there we have our second graph. And we can move this so it's off of our chart. And again, we want to select this one so we can remember what the title is. And this one is age versus circumference. And you can label your axes in the same way. Alright, so I'm not going to go through the rest of them. I think that's pretty self-explanatory. You're going to do the same thing with age versus diameter and age versus number of branches. Now, to tell which of these has the best correlation with age, I'm just going to take you back to our lab real quick. And if you look at this paragraph down here, so we just completed step 1 and then part of step 2 here, graphing each variable one by one against the age, although we only did 2 of them. Here, it now says something that might be complicated if you're not sure what an R-squared value is, but basically, we want to determine the R-squared value of each of the lines in the graphs that we just created. And it's very simple to do in Excel, but the point here, if you look at this last sentence, after graphing each variable against age, you're going to determine that R-squared value, and then you're going to choose the variable that has the highest R-squared value. So the highest R-squared value is going to give us the best correlation between that data. So the way that we do that, and again I wrote that down here for you, I wrote all of these steps as I'm saying them down here. So to calculate the R-squared value, you're going to select your graph. So you're going to actually click the graphing line. You'll know that you clicked it once you see the data points highlight. Then you're going to right click and go down to Add Trendline. When you do that, you're going to see all of these trendline options open up in this window. And down here you'll see a nice little box that indicates that you can display the R-squared value on the chart. So go ahead and select that, hit close, and now you'll see that there's this new line that's been plotted, and up here we have that R-squared value. So it's an R-squared value of 0.97. I would say that's pretty high. Now just to compare them, let's take a look at the R-squared value for age versus circumference. So again, we click the line so it's highlighted. Right click, we'll add that trend line, select display R-squared value on chart, and hit close, and voila, there's our second R-squared value at 0.99. So far, looking at this data, again noting that I only have a few data points in here, age versus circumference is the best correlation of age. If we determine that this ends up being our best correlation, the next thing you're going to want to do is establish what is the relationship between age and circumference. What's the relationship here? And you can do that with a simple division. You can figure out what the correlation is. So then when we go back, to our lab. So the next part of the lab, we'll have figured out which variable correlates best with age at this point. You're then going to use that information to fill in this data sheet, the original one that we looked at, and figure out the ages of all the different trees in this data set. So you're going to know by looking at this data. For example, if we go back and let's say that this tree is 13 years old, if circumference is the best variable, it's 60 centimeters in circumference. So if we go back to this data table, we can find a tree right here. So the circumference of this tree is 60 centimeters, which means that it must be 13 years old. So you'll fill these ages in for all of these trees after you figure out that best data set. Go back to your lab. And lastly, you'll make an age structure diagram with each of those trees. And I'll show you how to do that real quick too. So I have data here for just a male and female population that I just made up real quick. I put some age groups here. For this lab, you're going to have the age groups of the trees, and you can divide them up into whatever ages you want. And then we don't have a male and a female, so you can just put half the trees on one side and half the trees on the other side. It doesn't really matter. Just one of them you need to give a negative value to. Well, this one needs a negative, so that they're going to get plotted on opposite sides. So to make an age structure diagram, you're going to highlight all of the data, including the titles. You go to Insert, Chart again, but this time we're going to use a bar chart. And I like the 3D charts. And voila, we now have our age structure diagram. Our labels are already included because we selected them up at the top. So we know that the male population is over here, the female population is over here. So by looking at this age structure diagram, we can see that the female population has greater numbers than the male population. So you'll be using this data to figure out which forest will be best suited for the lynx reintroduction. And lastly, you will fill in that lab report to figure that out. Alright, if you have any questions about what I just went over, please shoot me an email. Thanks and have a nice day.